Welcome back to Learning with Jelly. Today we're going to talk about Bayes' theorem. This is going to be the first part of a two-part session. We're going to try to go through Bayes' theorem in roughly 5 to 6 minutes, so let's get started. So on our agenda for today, we're going to go through the Bayes' theorem formula, and then we're going to do a practice problem. So the Bayes' theorem formula is a formula of conditional probability. It answers the question, what's the probability event A has happened given event B has already occurred? This straight line called the pipe is called given in this formula. So let's break down this formula. On the left-hand side, you have what we call the posterior probability. It's the answer you get back out. I always remember this because posterior means the back. In the formula, it's the probability of event A given B. So for example, the probability I carry an umbrella, event A, given it's raining, event B. On the right-hand side in our numerator, the first term that we have is the likelihood. It's always the opposite of the posterior. So you notice that on the left-hand side, we have the probability of A given B. The likelihood is the opposite of that, the probability of B given A. So for example, the probability it's raining given I carry an umbrella. Right next to the likelihood, we have the prior. The prior is the prior knowledge you already have. Either somebody has told you some knowledge, you have a data set, and you can look at the target column to get out the knowledge, whatever it may be. And it's what I know from my data that there is a 70% chance it will rain on any given day. In the denominator, we have the marginal, or sometimes called the normalization factor. It's the probability of B given true. So there is a probability I carry an umbrella if it is raining or if it isn't raining. So there are two scenarios in which I can carry an umbrella that I want to capture in my denominator. So once again, the formula, we have the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. So let's look at an example. So on any given day, the probability that it may rain is 30%. This is prior knowledge that I already have. If it is raining, so given that it is raining, the probability that I carry an umbrella is 80%. Since I like to be shielded from the sun, there is also a 40% chance I carry an umbrella on non-rainy days. Given that I carry an umbrella, what is the probability that it is actually raining? So we have the key word here, given, that shows us is conditional probability, in which two events are dependent on each other. So what are these two events? It's either going to rain or not rain, or I'm either going to carry an umbrella or not carry an umbrella. So let's look at rain versus no rain. So in my word problem, it's underlined in a blue. I see that there's a 30% chance that it would rain. So that means that there's only a 70% chance that it won't rain. Since 1 minus 0.3 is 7, and we have to have our probabilities add up to 1. If it's raining, I have two choices. I either can carry an umbrella or not carry an umbrella. The second line in my scenario says, if it is raining, I carry an umbrella 80% of the time. So that means if it is raining, I will not carry an umbrella 20% of the time, since my percentages have to add up to 100. This is very true for when it's not raining. So that third sentence tells me that there is a 40% chance I carry an umbrella on non-rainy days. So given that it is not raining, there's a 40% chance that I carry an umbrella, which means there's a 60% chance that I don't carry an umbrella. So let's actually write out all of these variables. So everything that we drew in our tree diagram is now written out in terms of probability. Notice that the probability of carrying an umbrella, given that it's raining, is 80%. That came from the 80% directly from my tree diagram. Now, the question that I'm asking is, given that I carry an umbrella, what is the probability that it's actually raining? So here in red, I see that I'm trying to find the probability that it will rain given I carry an umbrella, denoted by U. So let's first write out our Bayes theorem formula. So the probability that it will rain given I carry an umbrella is going to be equal to the likelihood. Notice that this is opposite of what my posterior is, multiplied by the probability that it will actually rain divided by the probability that I bring an umbrella. So in this case, the probability that I bring the umbrella, given that it will rain, is 80%. I can see that on the left-hand side in my tree diagram that given that it is raining, I will carry an umbrella 80% of the time. Let's figure out what our second term in the numerator is. The second term in the numerator is the probability that it would rain. I said in the first sentence that the probability that it will rain is 30% of the time. Now, let's move to the denominator. Here we see that I can bring the umbrella based off of two different scenarios. I can either carry an umbrella if it's raining, denoted by this first green box, or with my plus sign, I can carry an umbrella when it's not raining. So my denominator is going to be these two numbers multiplied together, which is 0.3 times 0.8, since that's when I can carry an umbrella, plus these two numbers added together, which is 0.7 times 0.4. I now conclude that there is a 46% chance, given that I carried an umbrella, that it is actually raining. That's our first part for Bayes' theorem. Please stay tuned for the second part, in which we're going to talk about Bayes' theorem in diagnostic testing. It's going to help us answer the question, what is the probability I have the disease given a positive test result?